Yes, I'm going to talk about our experiences from running Puppet Masterless at Spotify. And a bit who I am was already introduced. But yeah, I've been working at Spotify as a system engineer for almost 3 years now, and working quite heavily with Puppet stuff. I'm in the team that has called commit to deploy, so we handle all kinds of continuous delivery. So far, me and Johan, that's sitting here in the audience as well, has mostly focused on configuration management, but it's about to be expanded to a bigger focus on continuous delivery as a whole. And I'm a community contributor to Puppet. As you heard earlier, I'm also the author of the Puppet Explorer web user interface. I've done the PuppetDB query module, which is for easy querying of PuppetDB data in a more human-friendly way instead of machine parsable way. I've also done some other smaller modules like DNS queries. You can do DNS queries from inside Puppet manifests, PuppetLS, which is like a utility for listing files handled by Puppet, and also a bunch of various fixes in Puppet Factor, PuppetDB, that sort of stuff. And as you heard, I won that award as well, so known for many things in this community, I guess. A bit about what I'm going to talk about today. So I'm first cover a bit of the background of our Puppet setup at Spotify. Then a bit about how we've implemented Masterless so far, and why we did the switch to Masterless, and also new workflows that enables and some future improvements. So first about the background. We've been using Puppet for a fairly long time before I started at Spotify. So for a bit more than 4 years now. And it's, at the beginning we started small, managed a few things with Puppet. I think the monitoring system was the first thing we managed with it, but that's been expanded to more and more things, and now we do, all configuration management with Puppet for all applications. We have 2 larger Puppet installations. So we have one for our testing environment and one for our production environment, and they're completely separate installations with different Puppet CAs and so on, with different PuppetDB instances, but they share the same code base. We also have another installation for managing desktops and laptops, which has a different code base. So far, we've had a single repository with all modules inside that repository and all the higher data and so on. And then we have branches in that repo mapped to Puppet environments. So when you're running a Puppet on a node, you can specify what Git branch you want to run it against, and it will run against that. And then we use Gerrit for code reviews. So any developer or operations engineer can push to private Git branches. You can run Puppet against those branches. But before it gets merged into the production branch, you have to go through a code review. And that also does things like Puppet lint testing and syntax validation, those sorts of things. And it actually also spins up a VM that where it runs the Puppet manifests on that, but only the kind of baseline installation so far, and does some sanity checking that the VM works as expected, even after applying those. Oh yeah, that's what I covered. So to start off with the implementation, this is a bit complicated diagram, but we started off with just replicating the exact same workflow as we already had using Puppet Masters, but with Masterless instead. So to do that, there's still quite a few components involved. You can't just like get rid of the Puppet masters and have less components to manage. So we have like Git mirrors in every site. We have a small secret distribution service that I'll get back to later. And though Gerrit does push replication to those. And then we still have PuppetDB. We have the one Puppet master that runs the Puppet CA. And we have some internal inventory system, one called ServerDB, which has like an inventory of all the servers, and also LDAP. So that's shown in this diagram because now the nodes are querying those services directly. And before, the queries to those systems came from the Puppet master. And then we have a custom Ruby wrapper around Puppet Apply. So we used to have a shell script called SPPuppet, SP for Spotify. Most internal utilities have that sort of naming standard. But now when we switched to Masterless, we needed access to a lot of like Puppet settings and internal Puppet APIs. So we converted it to a Ruby script instead, which is actually a Puppet application that inherits from Puppet Apply, and then overrides some of the methods, so the setup methods and that sort of stuff. So now it does the Git checkout, those sorts of things. So when you run Masterless, you need all the manifests on the nodes themselves. They get compiled there. So before it runs Puppet Apply, Puppet Apply, it does the Git checkout. It also fetches secrets. But it also does things like fetching a certificate if it doesn't have one. So it's calling the methods normally in the Puppet agent that aren't in Puppet Apply to check that it has a certificate. If not, go fetch one from the Puppet CA master, and those sorts of things. So it's a bit custom setup there, but it's not rocket science. But at the moment, it has a few Spotify-specific bits, but we'll try to refactor out some of them and see if we can push some of those changes upstream. Already been able to do it with some of the smaller changes, like adding the --test option to Puppet Apply, for example. So what are the benefits of this setup? And even with just the same workflow, there's some benefits we get right away with running Masterless. For example, when you do the compilation on the node, it's much easier for someone to get the debug logging from the compilation process, from all the higher lookups. We can just run with --debug now, and you get like all the debugging output from that, not just from the application of the catalog. If you're developing custom functions or custom Ruby types and have some error in them when you're developing, you can get the Ruby traceback directly on the node. It's not just logged on the Puppet master. So it's much easier for regular developers that don't have root access to the Puppet master to be able to do this. You get deprecation warnings from the compilation visible on the nodes themselves. So now with Puppet 4 upcoming, there's a lot of things that are being deprecated, syntax in templates, those sorts of things. Now when you run Puppet Apply, you get those directly in the console output when you're developing your code. So they're not just logged on the Puppet master, hidden from the users. But there's also some drawbacks of doing this. For example, it requires more configuration. So we need a bit more configuration of Puppet itself. You need to, as we're using PuppetDB, we need to configure the PuppetDB terminus on all the nodes. So that's 2 config files, both the PuppetDB.conf and the routes.yaml to specify that it should send facts and so on to PuppetDB. And as this is configuration Puppet needs to run, you can't use Puppet to manage this configuration. So you have a bit of a chicken and egg problem there. So in this case, against like our normal standards, we ship the configuration with the Debian package and use the Debian package to manage configuration. But we also have some sanity checks inside this script that checks that like most of the required configuration is as it should be. And otherwise, it will copy the default config files in place and restart itself. Another drawback is that it's a bit specialized. I mean, it's not as common setup, so we can encounter some bugs that others might not encounter, that sort of stuff. So, but in this case, we have people on staff that are fairly knowledgeable about Puppet, so that's all right in our case. I should take some water. Another thing about running Masterless is secret management and how you manage that, because you get a bit different access policy and so on to the secrets. I mean, as I said, you need to distribute the manifests to the nodes themselves. So it doesn't just get the catalog from the master. So yeah, managing secrets has to be done a little bit differently than you can do with a master. So what we've done there is that we've developed a small web service. It's called Poppy. It's a very simple web service, really, but the nodes authenticate against it using their SSL certificate. Then that web service figures out like what role the nodes has, what site they're in, if it's in the testing environment or production environment, those sorts of things. And then it zips up the higher YAML files with secrets that should apply to that node and sends it just those files. So the nodes can't get the files with secrets that apply to other nodes. So if I need a database password for like the playlist role, I put it in the role/playlist.yaml file in our secrets repo, and only nodes with that role will get that secret. Yeah. And also, another thing you have to think about is access control for PuppetDB. So normally, PuppetDB has a pretty binary access control. It's not like in the Puppet master itself, where you have an access.conf and can specify exactly what APIs different nodes can access and that sort of stuff. In PuppetDB, the default mode is that all nodes can access everything and send commands on behalf of any node, which is a bit odd. But it has an option to specify a whitelist, and if you do that, only those nodes can actually access anything or send any commands. So if you're using a Puppet master, you can specify like your Puppet masters, whitelist them, and then only the Puppet masters can access PuppetDB information. Because I mean, if you're sending out secrets, you maybe have some sort of file that contains the database password or something like that. That will be part of the catalog, so it will be stored in PuppetDB as well. So what we've done there is that instead of the nodes directly going to PuppetDB, we've put an Apache proxy in front of PuppetDB. And there we're using mod xfilter. So the node that authenticates using the SSL cert to Apache, and that handles the SSL negotiation, that sort of stuff. So it it proxies to the non-SSL port of PuppetDB. And then it uses modX filter so the requests or the responses from PuppetDB go through modX filter it's a filtering module for Apache that calls an external command. And that external command expects it's a regular Unix filter, so it gets the input on standard in and gets the filtered output on standard out, or sends the filtered output on standard out. And so there we do things like filtering. For example, in our config, any node can query for resources, but it can't see the parameters. It just filters that out, except for exported resources, where it passes them through. And we also have so that you can tag a resource with public, and then it will also send the parameters through the filter. It can also do things like checking the payload of commands to see that the node is actually sending a command on behalf of itself and not for some other nodes, like replacing the facts for another node. So that's a bit how we've solved that. I put it on a gist on my GitHub, that filter, but maybe it should be updated, and I should probably make a proper Puppet module to manage that, like a public Puppet module soon. So a bit about why we switched to Masterless. We didn't do this whole switch just to get slightly better debug logging on the nodes. That would seem a bit like a waste. And scaling the Puppet masters wasn't really an issue for us either. I mean, that would otherwise maybe be one reason why you would switch to Masterless, because you don't need to scale any Puppet masters anymore. All the compilation is done on every node. But you still have to scale those Git mirrors, or the distribution way. Possibly that's an easier thing to scale, or it can handle more load per node, but still. But scaling the workflow was an issue for us. So this workflow with having all the modules in one big repository and having Git branches mapping to environments, it worked very well for a very long time, but now we're starting to see the limits of that workflow. So over the years, we've had a growing amount of committers. So this graph shows, for each individual month, how many unique committers we had to our Puppet repo. So over the past 2.5 years, that's grown from a bit less than 50 to around 200 every month now. So there's a lot of work going on at the same time, tons of stuff being changed in parallel. On average, we have around 40 commits being merged into the production branch every single day. So that's quite a few code deployments. We've also had a growing number of modules in our Puppet repository. So we have one module for each backend service, also a bunch of shared modules for things like syslog or Postgres, Apache, Nginx, these things that are shared between a lot of services. But it's definitely grown quite a lot. And now I think on average we had 2 Puppet modules every week or something like that. So I don't know what all of them are doing really, but it's quite a few of them. And as you can see on this graph, I mean, we're up to 560 Puppet modules at the moment in that repo. So because of this, you get a lot more complex dependencies. For example, in our Puppet repo, there's 126 modules that are using the Apache module. We have 91 modules that are using the Nginx module. We have 92 modules that are using the Postgres module. So because of this, I mean, backwards incompatible changes are almost impossible to do. If you want to do it backwards incompatible change in the Apache module, at the same time, you need to change 126 other modules to accommodate for that change. And I mean, pushing out that change all at the same time is really, really scary. So you tend to just avoid doing it. So we needed a more flexible workflow. So what we want is to allow the nodes to have one set of modules per Puppet run, determined by hierarchy. And we wanted to have easier ways of doing continuous delivery of both application and configuration, to be able to roll them out, new versions of them at the same time. And we also wanted to be able to do gradual rollout of new module versions. So why not use RTNK or Librarian Puppet? Those are both great tools for managing which modules should be used and those sorts of things. Take some water. They can both build an environment dynamically, so you specify which modules should be installed in this environment. They can fetch it both from Git or from Puppet Module Forge, resolve dependencies, that sort of stuff, and build an environment for you. But it's still like a fixed environment for many nodes, so you can build your production environment or some testing environment and which module versions you want to use in that environment. But it's still like everyone using the production environment still has the same set of modules, or everyone using the testing environment. So if you want to upgrade the Apache module, you'd end up with like, if you want to do that gradually instead of on all 126 other modules at the same time, you end up with a separate environment for like, this is production, but with the new Apache version. But what if someone wants to upgrade the Postgres module and do a backwards incompatible change of that at the same time? I mean, as I said, we had almost 200 people actively working on the Puppet code at the same time. So you can't just like limit it to only do one gradual rollout at a time. So then you end up with like the production environment, but with new Apache and new Postgres. And some of them have only done one of the migrations. You have old Apache, new Postgres, and new Apache, old Postgres. And I mean, as you can imagine, with 560 modules, the number of combinations you can get is almost endless. So our solution to this problem is that we've been in the setup stage of this wrapper script. We look in the hierarchy data. So as I said, first we do this git checkout with the Puppet repo containing all the hierarchy data and all the modules. And then we take a look in the hierarchy data and see for a key called modules that specifies which modules should you install on this node. So then you can do something like this, for example, where you have a common YAML that specifies that you want to use our host base. That's our module for like the baseline configuration. And then on our Spotify web, maybe we're using the old Apache module, old internal one called Spotify-Apache. But on Puppet Explorer, which is a new application, we want to use the Puppet Labs Apache module. So then we can do like this, and it merges together and like the different hierarchy levels. So on the Spotify web nodes, it will install our own Apache modules, but on the Puppet Explorer node, it will install the Puppet Labs Apache module, even though they're both in the production environment, and they They share the rest of the code in the production environment. They share the same higher data and that sort of stuff. And I mean, here it specifies latest on all of them, but you can specify a major version or any kind of semantic version specification. And it uses the Puppet module tool to do these installations. So it basically loops through the modules you have specified and does a Puppet module install on all of them before it starts the actual Puppet run. So, I mean, in this case, it specifies the Apache modules, but really you could specify the actual module that service uses, and it will install all the dependencies for that module, as the Puppet module tool handles dependencies quite well. And yeah, so you could also use it for like having PostgreSQL 1.x on one node and PostgreSQL 2.x as the module versions on another node. So then it's much easier to do a kind of gradual rollout or like one roll at a time and that sort of stuff. Or easily upgrading the whole testing environment first and then the production environment. So in our setup, actually all nodes, even in the testing environment, run on the production branch. You can like temporarily change them to run on some other branch, but we don't have a fixed testing branch where things go through before going to the production branch. We just have production branch and feature branches, basically. So to do these module installs, we, of course, needed an internal forge. I mean, if you only want to install publicly available modules in your environment, you can use the upstream forge, of course. But for most cases, I mean, you have modules that are internal to your company that you don't want to publish as open source. So then you need an internal forge to pull them from. So we've created a simple forge implementation using the new version 3 Forge API. It mirrors the upstream forge. So even when we're installing like publicly available modules, we don't want to rely on the Puppet Labs forge being up. We don't want to have like test runs breaking because the Puppet Labs forge is down for an hour or something. So we just mirror all of it internally and have one of these Puppet forges in each data center. Also, so you get a lot quicker installs of the modules. As I said, they do the install on every Puppet run, so you want it to be fairly quick so you can see the results of the Puppet run quickly. At the moment, they only mirror the upstream forge, actually. So we haven't started using this system yet for distributing internal modules. The plan was to have that done by now, but we had a bit of a security incident in the spring and early summer, and yeah, got caught up with a lot of work to do with that. So, I mean, we don't only do Puppet stuff. We have a service to run as well, so sometimes things get in the way. And yeah, so we haven't gotten as far in this work as we would like to, but so in the future we will use this for distributing internal modules as well and like building them in Jenkins and these sorts of things. And I mean, that also makes it a lot easier to split up this big repo into smaller repos. So for example, that's been a common request from our developers to have the Puppet code for their service in the same repo as the rest of the service. So our plan is to solve that by having just a Puppet directory in the regular service repo. And when the build triggers for that service, it builds the Puppet module as well. does all the testing it should do on it and uploads it to this internal forge. But as I said, at the moment, we're only using it for mirroring the upstream. It's available, this Puppet Forge implementation at this address. It's mostly Johan that's done it. It's coded in Go. We did an earlier implementation in Ruby, but Johan wanted to learn Go, so we've done a Go implementation. We'll see. Maybe in the future we should do a closure implementation on Trapper Keeper, merge it into the Puppet server. So yeah, that's actually all I had for today. So do you have any questions? I can barely see you though due to these bright lights, but shout. Yeah.
What about, you're putting your hierarchy configs on these nodes. What about security implications? Do you have any? I mean, sharing configuration data with all the different nodes all throughout. How do you manage? Do you encrypt passwords and things like that, or do you have any of those concerns?
So how we manage security concerns with putting the hierarchy data on all nodes. So with the hierarchy data, we have it split up into two different repositories. So we have, in this big repository, we have all the regular hierarchy data and like config parameters. But things like security sensitive things, private certs, private keys, SSL keys, passwords, that sort of stuff is in a separate repository. So there's a very limited amount of people that can access that repo. And we use that web service I mentioned earlier to distribute files from that repo to the nodes, but they only get the files that apply to that specific node with the secret ones. And we actually will have a small web service there where people can change the secrets for the services that their team owns. So they don't have to bug us to do the changes in the Git repo. They can just do it themselves. But they can only change the secrets for the roles that their team is responsible for. If that service is available as open source, not at the moment. We should really do that. There is a bit of Spotify-specific code in that service because it uses the cert name to figure out which facts that node has, so which hierarchy levels that node should get. At the moment, it does that entirely in Ruby code. We could probably fix that by having some sort of like named regex matches or something like that to figure it out, and then we could make it a bit more general, so possible for anyone to use it. But at least at the moment, you'd have to plug in your own code for figuring out which facts that node has, and based on the cert name, and which files it should then get. But then once it's done that, it basically just puts them in a tar gzip and sends them to the node, and that one uncompresses that. So it's only a single request for the secrets at the start of each Puppet run. Because within Hira, I mean, Puppet calls Hira for every single parameter in every single class when it does the compilation. So you don't want to do like a network call for looking up each single parameter value. So that's why it does this fetch at the beginning of the run, and it's like just YAML files that it puts on disk, makes them only readable to root, and then just uses the regular Hira YAML backend to read the secrets from those files. So that's pretty quick. Yeah, question over there.
You mentioned that you have, I think, around 500 modules of your own. Would you be able to comment on whether you feel like that's something you guys would want to refactor? Because it sounded like that was part of the motivation for following this type of topology.
The question was about that we have like 500 modules, and if we want to refactor that, or if that's our plan. Yeah, I'd say it's a plan to refactor it. I mean, some of those modules are upstream, like publicly available open source modules. Some of them are our own modules. As I said, we've been using Puppet for 4 years now, or more than 4 years. So, for example, we had our own Apache module, our own Postgres module, our own Nginx module, and they're used by a lot of other modules. So it's very hard to just replace them with the publicly available ones. But if we think that this system will allow us to do it like kind of step by step, so we can have some nodes running with open source Apache modules, have some nodes running with our own internal Apache modules at the same time, even though they're in the production environment otherwise. But I mean, the amount of modules, it's a kind of rough estimation of how much code there is. You can sometimes, I mean, some of the modules maybe could be merged into a single module. For some of them, it might make sense to split them into 2 or 3 modules. But it's a rough estimation of like how many there are that we have to deal with.
How do you distribute your Hiera data that's not secret?
So how we distribute our Hiera data that's not secret? So that lives inside the same repo as all the modules at the moment. So this big old repo. So I mean, our plan is to gradually move modules out of that repo and basically eventually maybe have it to be only Hiera data in that repo. But the way they get it at the moment is that we have these Git mirrors in each site. So Gerrit will do push replication to these Git mirrors, and then it basically does a Git fetch on the node to get those. It uses Git over HTTPS and uses the Puppet client certificate to authenticate to those Git mirrors. So that's how they authenticate to get the Hiera data and manifests. Yeah, question over there.
You mentioned one of the reasons for moving to this was workflow related, and gave a stat of roughly 40 commits per week or something per day, something like that. Do you have any idea of the complexity of those commits? I mean, are they entire new modules, version changes?
So a bit about the complexity of the commits, like that we have 40 commits per day, and like if we have any stats, if those are complex commits or simple ones. No, I don't have any like detailed stats on it. I mean, it's a mix. Some of them are entirely new modules. Some of them are like upgrades of a publicly available module. Some of them are just smaller changes. I mean, for some of those commits, they only change like a template or something, so they don't even change any like actual Puppet code, just like a small change in some config template or something like that. So it's a big mix, really. But yeah, most of them are like for a single service and that sort of stuff. But it's Gerrit basically forces you a bit to squash commits together, so it's not like a ton of like typo commits and like that sort of stuff. So as Gerrit doesn't work with like pull requests where you merge a whole bunch of commits at the same time, like you review and merge a single commit at a time. So they're all like real commits, kind of. Yeah.
What are the benefits of running your own forge versus using R10K to deploy modules from Git?
The benefits of running our own forge instead of using R10K to deploy for Git. I think this will be the last question. The time is running out, by the way. But so the reason we do that is that we're at the moment access to all the Git repos. Like if we're splitting it up in a lot of smaller repos, we would either need to replicate all of those smaller repos to those Git mirrors, or you would need some sort of authentication to Gerrit or GitHub Enterprise that we're also using to be able to read those repos. So it's a bit tricky to manage that, the authentication to the Git repos. I mean, at the moment, normally only like developers use their own authentication, their personal user to fetch Git repos, but you can't use. We don't want any like machine users on every single node that can access all the Git repos. So then it's easier to have a forge and build artifacts and put in that forge. All right, I think I have to end there because the time says 0 here. Thank you.